Hey everyone, housing prices in America, they're absolutely wild right now, aren't they? Today we're diving into a fascinating Just Name It challenge. We'll discover how housing prices have evolved over time and discover which regions saw the most dramatic changes. And we'll visualize the impact of the 2008 financial crisis on the housing market. Plus, I'll show you a really cool way how you can get data directly from the web without downloading anything to a local file. By the way, if you are new to KNIME, I have got a comprehensive beginner's guide video linked at the top. So just go there if you never heard about KNIME Analytics platform before. Are you ready? And let's get started. Alright, let me walk you through what this challenge is asking us to do. We have four main tasks here. First, read the housing price dataset directly from its URL, no local downloads. We'll use the CSV reader node for this. Second, take the monthly data, calculate yearly averages, and visualize the three regions with the most drastic price changes from the earliest to the most recent year in the dataset. Third, find which US state currently has the lowest average home prices. And fourth, visualize how the 2008 Lehman Brothers bankruptcy, which marked the climax of the subprime mortgage crisis, impacted the housing market. We'll keep this visualization clean by focusing only on those three regions we identified in task number 2. Now, here's what makes this interesting. We're going to build this workflow to be completely dynamic. That means if the data updates tomorrow, next month, or 5 years from now, you still have a working workflow that will execute its tasks like clockwork. Let's dive in. For task 1, instead of downloading the dataset to our local machine, we're connecting directly to the data source using the CSV reader node. I'm simply providing the web link to the dataset in a node configuration. Now, why is this approach interesting? Well, this ensures we're always working with the most current data. As of the recording of this video, the dataset includes information up to September 30th, 2025. If new data gets added next week, our workflow automatically picks up the next time we run it. Think for a moment how you would have handled this in Excel. You'd have to manually download the file, update your formulas and functions, replace the old file. With KNIME, we connect once and we're done. The workflow stays current automatically. This is where things get interesting. We need to transform monthly data into yearly aggregations and then identify the top 3 regions by price change. We're using a row filter to exclude the first line, which contains the country average. We're only interested in individual regions and states throughout this analysis, so the country level data doesn't help us. Here is the key transformation. Our source data has over 300 columns, one for each month. That's a really wide table. The Unpivot node restructures this so we have just one column for dates and one column for housing prices. We are retaining the region ID, size rank, region name, region type, and state name as retained columns. Why do we do this? Because working with long format data in KNIME is much more flexible for aggregations and visualizations. After unpivoting, we clean up some column names and then use the string to date and time node to convert our year-month text into an actual date format that KNIME can work with mathematically. The date and time part extractor pulls out the year and month from our date column. We don't need the day since the data always uses the last day of each month anyway. Now we use a group by node to calculate the mean housing price by region and year. This gives us yearly averages instead of monthly data points. One thing you'll notice, this creates some missing values because not all regions have consistent reporting across all years. That's totally normal with real-world data. We use another row filter to delete rows with missing housing prices since they won't benefit our analysis. Here's where the logic gets clever. We split into two branches, each with a group by node. In the first branch, we group by region name and use the first aggregation method on both year and mean housing price. This captures the oldest year and its corresponding price for each region. In the second branch, we do exact the same grouping, but we use last as the aggregation method. This gives us the most recent year and price for each region. Why first instead of averaging in the aggregation? Because we've already calculated averages in the previous group by. Averaging an average doesn't make mathematical sense here. We just want to take the value as is. The joiner brings these two branches back together with an inner join on region name. Now we have one row per region showing both the oldest price with its year and the newest price with its year. The math formula node calculates our price change percentage. We divide the newest housing price by the oldest housing price, then subtract 1. This gives us the percentage increase or decrease. The top K row filter node limits our results to just 3 rows, sorted by price change percent in descending order. This gives us the 3 regions with the highest percentage increases. We use a column renamer to change the aggregation generated names to something more readable, earliest and latest, for our year columns. Finally, we create a bar chart with region name as the category on the x-axis. We set aggregation to none, since we've already done all our averaging. We include only the earliest and latest price columns to create a clear before and after visualization. And here you have it, a crystal clear view of the 3 regions with the most dramatic price change. The entire workflow is dynamic, so if different regions rise to the top in future data updates, our workflow will automatically adjust. Pretty powerful, right? Reading data directly from the web and having everything update automatically, that's the kind of workflow efficiency that makes KNIME shine. If you're finding this helpful, hit that subscribe button and ring the bell so you don't miss any future KNIME techniques just like this. Task 3 asks us which state has the cheapest housing right now. The keyword here is currently. We need to work with the most recent data and not historic averages. We're creating another branch from the date and time part extractor node we used in task number 2. This gives us access to the cleaned, date formatted data. We use a group by to calculate mean housing price by state and date. This gives us each state's average price for every reporting period. Here's a really elegant technique. The date and time difference node compares our reporting date to the current execution date whenever we run this workflow. We calculate the difference in days. This tells us how old each data point is relative to right now. We create a small side branch with another group by node, and this time we are not grouping by anything, we're just using manual aggregation to find the minimum value in that date and time difference column. Then we use table row to variable to convert this into a flow variable called minimum date and time difference. This variable now holds the smallest gap between execution date, today, and reporting date. In other words, it identifies our most recent data. Back in our main branch, we have a row filter that uses this flow variable as its criterion. We're only keeping rows where the date and time difference equals our minimum value. This filters down to just the most current reporting periods across all states. Finally, we use another top K row filter node, limiting to just one row. We sort by mean housing price in ascending order, smallest to largest. This puts the state with the lowest current housing price at the top. And there's our answer, the state with the cheapest current housing prices. Again, completely dynamic. No hard-coded dates, no manual filtering. Run this next month and you'll get next month's updated answer automatically. For our final task, we want to visualize how the 2008 Lehman bankruptcy affected housing prices. To keep things readable, we'll focus only on these 3 regions we identified earlier in task 2 with the most dramatic changes. We use a column filter on the results from task 2's top K row filter. We're keeping only the region name column. This becomes our reference list. The reference row filter node is perfect here. Our main transactional data, coming from the row filter where we removed missing values in task 2, goes into the top port. Our 3 region reference list goes into the bottom port. We configure it to only include rows that match these 3 regions. The pivot node reshapes our data one more time. We group by year, pivot by region name, and aggregate mean housing price using first again. Since we've already done the averaging, we just want to preserve the values. The column renamer node cleans up the pivoted column names. Instead of having aggregation method names in our chart legend, we want the actual region names as they appear in the source data. Now I need to point out something here. This step makes task number 4 less dynamic than the others. These region names are hard-coded. If the top 3 regions change dynamically in a future update, you need to adjust this node manually. It's a trade-off between automation and visualization clarity. Finally, we use a line plot. Year goes on the horizontal x-axis, and our 3 region prices go on the vertical y-axis. One critical configuration here. In the axis limits settings, we set the horizontal axis to use domain bounds. This means the axis starts at the minimum year in our data and not at 0. Why does this matter? Our data starts around the year 2000. If the axis started at 0, we'd have 2000 years full of empty data fields starting on the very left-hand side with 0. And that would probably completely destroy the visualization. And here's our result. You can clearly see the housing price trajectories for our 3 regions over time. If you look at the 2008-2009 timeframe, you can see the impact of the financial crisis. Prices either stagnated or declined during that period before recovering in subsequent years. But just look at the increase over the past few years. Does that mean we run into another crisis again? Well, you have to ask yourself. And that's it. Today we tackled a comprehensive housing price analysis, reading data dynamically from the web, calculating yearly trends, identifying extremes, and visualizing the impact of a major economic event. We built most of this workflow to be completely dynamic. This means it will adapt automatically when new data becomes available. The techniques we covered, unpivoting, date calculations, flow variables, reference filtering. These are fundamental skills you'll use in countless KNIME projects. Want to level up your KNIME skills even faster? Join my newsletter. The link is in the description. This is your inside track to mastering KNIME and data analytics. You'll get exclusive content, workflow breakdowns, and techniques I don't share anywhere else. Thanks for watching and see you in the next one.